right, moving into trig identities, more in-depth trig proofs, verifying identities. So as a review, here are the identities that we have discussed previously. Make sure you know these. Quizlets are a great idea, flashcards, but you need to know these identities here and be familiar with them. Otherwise, you will struggle through these proofs because you're not sure what you're allowed to plug in where. Also, be very, very mindful of your algebra. Algebra errors are extremely costly when trying to verify a trig identity. So, moving into examples. There's multiple ways to verify a trig proof or verify a trig identity. So we're going to go through several suggestions for ways that you can get to the other side. So the first thing, what we're trying to do is we're trying to show that the two sides are the exact same by manipulating them using that list of identities that we were given at the beginning. So tip number one is when in doubt, all trig functions can be written in terms of sine and cosine. So if you don't know where to start, change everything to its sine or cosine form. All right. I put a vertical bar down to show the separation of sides. You can work on one side only. You could do a little bit of both as long as where you stop, they match. So I'm going to go to sine and cosine. So tangent of x, that's the quotient rule. Quotient identity, sine x over cosine x. Plus cotangent is cosine x over sine x. All right, since I changed to, that is a very crooked division bar, I would like to fix it. Change to sine and cosine here. Okay, well, let's get a single fraction because over here on the other side, I don't have a single fraction. So I know that's got to happen. So I'm going to multiply this by cosine over cosine so that the denominators are going to be the same. And then same thing on the first fraction, multiplying by sine over sine. All right, so top times top, bottom times bottom, that's going to give us sine squared over sine cosine, sine x, cosine x. Order you write them in doesn't matter, just be consistent. I usually put cosine first, so I'm just going to go ahead and do that now. I like to go alphabetical. Plus, and then the second one's going to be cosine squared over cosine x, sine x. All right, denominators now match, so I got one large fraction. Numerator 1, sine squared x, plus numerator 2, cosine squared x, over denominator cosine x, sine x. Sine squared plus cosine squared, that's one of your Pythagorean identities, that's Papa Pitt. That is 1 over, so I've got cosine x times sine x. And like I said, we said change everything to sine and cosine, so I'm going to go back. I'm kind of stuck here. I'm going to go back to the other side. Secant is 1 over cosine. Cosecant is 1 over sine. And then if I do top times top, bottom times bottom, I get 1 over cosine x, sine x, and to match. So when I finish, I do a little squiggle and an arrow to show I'm done. Next one. Tip number 2 is to combine terms by getting a common denominator. So no, we just did that, but it's a good strategy when you don't know where to start. So I'll get my line. So the left side is 2 separate fractions. The right side is 1 single term because everything's attached with multiplication. So that's why getting a common denominator on the left side would be a good idea. So we're going to multiply by a form of 1, swapping the denominator. So this is going to be secant x minus 1 over itself. On the other side, it's going to be secant x plus 1. All right, so that's going to give us secant x plus 1 over. Since the denominators match, I'm going to go ahead and make one fraction. And then secant x minus 1. And the denominator, I am going to leave it in factored form for now until I know if I should multiply it out. So secant x plus 1 and secant x minus 1. Again, you don't want to multiply it out and then realize you needed it factored, and then you have to go undo that. So looking at that numerator, the 1's drop. So I have secant plus itself. That's going to be 2 secant x over that secant x plus 1, secant x minus 1. And then I'm going to go look at the other side. So on the other side, I don't really see where to go next. So what I'm going to do is I'm going to go to my denominator now. I want to multiply it out because there's no way a factor is going to divide out based on that simplified numerator. So we're going to go through FOIL. So first outside, inside last. So first secant times itself, secant squared. It's a difference of squares, so the outside and insides drop, just secant squared minus 1. That is another one of your Pythagorean identities. The Pythagorean identity as written, I'll write it over here, is 1 plus tangent squared of x equals secant squared of x. Remember, you're allowed to manipulate these. So if we move that 1 to the other side, we can use this baby PID right here. So secant squared of x minus 1 is tangent squared. So we've got 2 secant x over tangent squared of x. So tangent squared in the denominator, we can think about that. So I'm going to scoochie it to the side as 1 over tangent squared. Well, 1 over tangent squared, I could use a reciprocal identity because I see cotangent sitting on the right side. So I could use a reciprocal identity to get cotangent squared. So 2 times secant of x, that 1 over tangent squared is equivalent to cotangent squared of x. And then we kind of sit and we're like, well, now what? So once again, if you're unsure what to do, you can always fall back on sine and cosine. So that's where I'm going. I'm changing everything to sine and cosine. So we've got our 2. Secant is 1 over cosine. Cotangent squared. Cotangent is cosine over sine. So cotangent squared is cosine squared over sine squared. Those reciprocal and quotient identities work for powers as well. So when I look at this, I have 2 powers of cosine on top, 1 power on bottom, so I can take it out, and that gets us to 2 cosine x over sine squared x. And then I'm in sine and cosine on the left, so I might as well go all the way back up here to the right and change everything to sine and cosine as well. So I've got my 2. Cotangent is cosine x over sine x. Cosecant is 1 over sine x. And if we go top times top, bottom times bottom, we get to cosine x over sine times itself, sine squared of x, and I believe that's what our goal was. Yep, we're done, and we match. All right, next idea is eliminate complex fractions. So we've got our identity here. Let me get my bar. So complex fractions are fractions within fractions. So if you first look at this, I don't see any, but I know that the reciprocal of secant is cosine. So I want to change those secants into cosines using my reciprocal identity right away. So secant 1 over cosine. And then another secant, also 1 over cosine. Then that creates those complex fractions. So we're going to multiply by a form of 1 along the main division bar, which is right here, to clear that little baby denominator, which is the problem of cosine. So that cosine is going to get distributed to the 1 over cosine and to the 1. And then the denominator cosine is going to also go to the 1 over cosine. That's not what I want. I would like an arc. 1 over cosine. Sometimes it gets mad at me. 1 over cosine. There we go. And the 1. So it goes to both as well. So 1 over cosine times itself is 1. 1 times cosine is cosine. Main division bar. 1 over cosine times cosine is 1 minus cosine x. And look at that. 2-step. So that's the beauty of these trig proofs, is there's multiple ways to do them. It's all going to depend on what you see first as to how you go through these examples. So just another note, the tips with the homework, some of these are going to be fill in the blanks where it tells you what to manipulate first. Others are going to be multiple choice. Be very, very mindful of the algebra as you go through those answer choices and choosing which one is the correct verification. All right, next one. Next tip is factoring. All right, bar. All right, so factoring. We can do factoring with trig just like we can do factoring with x's and numbers. So if I look at this, there are two terms here on the left. Term number 1 is cosecant x, and term number 2 is cosecant times cosine squared. They both have a cosecant in common, so we're going to factor that cosecant of x out. Just like we would factor an x out of an x squared minus 2x, we bring it out. That's going to leave us with a 1 for the placeholder for that first cosecant minus cosine squared x. All right, 1 minus cosine squared, that's Papa Pid rearranged. That is sine squared. And then cosecant is 1 over sine. All right, so sine squared times 1 over sine, I can take 1 power away to divide out the denominator, and that leaves us with a single power of sine. So that time we were able to stay all on the left. All right, example 5, multiply by a clever form of 1. So sometimes that's a little bit hard to see. So if I'm looking at this proof or this verification, whichever you prefer to call it, I tend to call it prove it. The book likes the word verify. So clever form of 1, if I'm looking at this, red flag, I see this 1 plus sign in the numerator on the right side. So I'm going to force it into the numerator on the left side by multiplying by it immediately. So my clever form of 1 is going to be the numerator I have to get to, 1 plus sine of x. So top times top, bottom times bottom. I'm just going to write it as a single fraction first. I like the cosine written on the front. Cosine times 1 plus cosine x over, 1 plus sine x, I wrote the wrong one. That's sine. 1 plus sine x. And then the denominator, 1 plus sine x times 1 minus sine x. So again, if you always know where you're trying to go. So if I look at the right side, I'd want to leave that denominator factored because the 1 plus sine x is where I need to be. So now I'm going to go to the denominator and I'm going to FOIL it out. So cosine x, 1 plus sine x, don't touch it. FOIL first, difference of squares, 1. Outside, inside drops. Last, negative sine squared x. That denominator is Papa Pid, rearranged. Notice we've used those a lot. 1 plus sine x over denominator. It can be subbed in with cosine squared of x, and then 1 power on the bottom takes out the 1 power on the top. So we have 1 plus sine x all over cosine x, which was our goal. All right, tip 6, work on both sides and meet in the middle. So sometimes it's hard to figure out exactly how to approach it if you're dead set on staying only on the left or only on the right. There's absolutely nothing wrong with doing a combination. So if I'm looking at this, first thing I would probably do is change that right side to, well, let's stay on the left side. Let's go ahead and get a common denominator. So I'm going to go squeeze 1 plus cosine x in here. And then same thing here, I'm going to squeeze in 1 minus cosine x. All right, so that's going to give us a common denominator, so I'm going to go ahead and do my extra long division bar. I'm going to get 1 minus cosine x plus 1 plus cosine x. All right, denominator, 1 minus cosine x, 1 plus cosine x. All right, so if we look at this, our cosines drop, and we're left with 2. Okay, well, I notice there's 2's over there, so 2. And then my denominator, I don't really know what to do with it besides go ahead and FOIL it out. So first outside, inside, last. That is going to be 1 minus cosine squared of x. 1 minus cosine squared, sine squared. So that is 2 over sine squared x. And then I'm kind of stuck. I don't know where to go next. So I'm going to stop because I got that left side very, very simplified. So I'm going to sit tight on it. And I'm going to go work on the opposite side now and see what kind of progress we can make. So if I'm looking at the right side, I notice they have a 2 in common. I'm going to factor that out right away because I have a 2 on the left side. So I'm going to bump the 2 out, which is going to leave me with 1 plus cotangent squared of x. That's a Pythagorean identity. That's one of your baby PIDs. So the way it's written, I'll come over here on the side, is 1 plus cotangent squared, you pair your cocos, is cosecant squared. So I can sub cosecant squared of x in directly for that set of parentheses. So that's going to be 2 times cosecant squared. Well, the reciprocal of cosecant is sine, so that's going to be 2 times 1 over sine squared of x. And will I just simply just slide that 2 into the numerator? 2 over sine squared x. And we have met in the middle and agree. So you can see by going through these, if you don't know those identities, it is going to be very, very difficult to figure out what can be plugged in where. Squared trig is a red flag for one of those Pythagorean identities. Tip 7, if you don't know where to start on the complicated side. You may also have to use multiple strategies. You've already seen we've used common denominators, we've used factoring, reciprocal. We've used a lot of those strategies all within one verification. So yes, the odds that you just use one is no, you're going to have to use multiple within one problem. All right, so if I'm looking at this, I'm going to go to the left side because that left side looks very complicated. It's in factored form. I want to undo that. So you kind of have some options here. You could go ahead and change to sine and cosine if you wanted to, or you could just multiply it out as is. Completely up to you. I would probably be going to sine and cosine immediately before I FOILed. So that's what I'm going to do. That's the wrong color. All right, so sine x, cosine x. And then tangent is sine x over cosine x. And cotangent is the reciprocal cosine x over sine x. Now I'm going to go through FOIL. So first outside, inside, last. So first, sine times sine over cosine is going to be sine squared over cosine. Outside, sine times cosine over sine. Those sines are going to divide out. That's just cosine. Plus, inside, cosine times sine over cosine. The cosines divide out, and that is just sine. And then last, cosine times cosine over sine is going to be cosine squared over sine. All right, so we're here. So be very careful with identities. That is not Papa Pid. That is not cosine squared plus sine squared. Cosine plus sine is not 1. They have to be squared. So next thing I would probably do is I'm going to look at, let's see, what do we want to do? We could slide, well, let's go to the right side. Let's go sine and cosine since these are already sine and cosine. So secant is 1 over cosine. Cosecant is 1 over sine. So with fractions like this, my recommendation, probably if I'm looking at this, I'm going to go common denominator it. You know, it's just, for me, that would probably be the easiest route to take. So we're going to go common denominator. I'm going to go cosine over cosine. And then I'm going to do the same thing back on the other side as well. so that's going to be top. That's going to give us sine of x plus cosine of x over cosine times sine. So I got this side down to a single fraction, so let's go do the same thing here. So that's going to require multiplying by sine and cosine on all four of these, because one's got a denominator of cosine, one's got a denominator of sine. So we're going sine x, cosine x, on all four. So you know what? Just because I don't really have room to squeeze that in here, this is what I'm going to do. Just to show it's all of them being multiplied. So we're going to go cosine x, sine x on all of them. All right, so this little fraction here is going to go to all four terms in that large set of brackets I just created. So that's going to give us, we've got sine cubed, so when we go here we'll do different colored arrows. We're going to go here. That's going to give us 1 power of cosine, 3 powers of sine. This is going to be fun. And then it's going to go to the next one. I'm going to put them all over one denominator at the same time. So 2 powers of cosine, 1 power of sine. And then it's going to go to the third one, which is going to be 2 powers of sine, 1 power of cosine. And I'm going to run out of room. And still scooching. And then finally, I'm writing on top of everything. That's okay. Go in here. And that is going to give us 3 powers of cosine, 1 power of sine. Ooh. All over, so extra long division bar. That's a crooked one. And then we have cosine x, sine x. Nope. Scratch that. Back up. See, I said algebra mistakes are very, very costly. Oops. Reverse, 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 reverse. Okay, let's try that again. I am going to scooch. Let's see. Let's do this a different way. That's going to be a nightmare. So I've got my cosine x, sine x single fraction over here. Let's pair these in groups. Rather than doing it all at once, let's just focus on them getting into groups. So let's go with these two. I want to get these two with a cosine in the denominator. Let's fill it. And then I'm going to also pair these two, but I'm going to get a sine in the denominator. And then we'll, because yeah, that route, that was not going to be a fun route. We don't want to do something that's going to be way too complicated. All right, so if I pair those up, that means that middle one is going to get a cosine over cosine. So I'm going to go here, cosine x over, so we're going to scooch that. So we're going cosine over cosine. Because I want to pair these two up. We're just going to do it in small chunks rather than one large chunk. And then we're going to do this one, sine over sine, so that the first two go together and then the last two go together. This will be a better route. So see, sometimes that's the thing with proof. Sometimes you got to realize that that was not a smart move on my part. So sometimes just stop, back up a step, and then keep going. It's okay to stop and back up. All right, so from the pink area, let's go ahead and extend it to match all of that. And we'll extend that one. We're going to get sine squared plus cosine squared, look at that, over cosine x. And then on the other two that are paired, sine, so we're going to get sine squared plus cosine squared over sine. And if I look, sine squared plus cosine squared, pop a pid right there, 1 over cosine, plus second pop a pid, 1 over sign. So if I look, I notice I went a little too far. I've already overlapped, so I can simply just go in and I could just exit out, but I'm going to erase it just so that the notes are nice and pretty. And just erase that step I did because it wasn't necessary because I've made a match if I just did that one. So that was a much better route than what I was originally going to suggest. And that's the downfall with proofs, is there's multiple roads that will work. So be really, really mindful of it. If it looks like it's getting a little too complicated, maybe you should stop and back up, check for algebra mistakes, see if there's a better road. So this was much better than where we were fixing to go. All right, with these proofs, be very, very mindful. Algebra steps will cause a lot of problems. So be very, very mindful of your algebra. Keep your work nice and neat. With the multiple choice ones, verify that the algebra is correct step by step.